Good afternoon, Keston, Alexi, Kendra, Lanisha, Monier, Nigel. If I didn't call your name, then I don't see you in the chat as having signed up for today's lecture. So please go there if you haven't done so and type your name in. Okay, before I get into today's lecture, are there any questions? Now, you may not have gotten the email because I saw where my email in Blackboard was not being sent. So I'll give you a few minutes to go into Blackboard and submit your homework. I am about to go over that. So before I do that, I give you about 10 minutes to just take your same answer that you circled when you're doing the work and put it in Blackboard so that it can be graded there. So please, if you haven't done so, I saw about 4 of you have done that. The rest of you have not. Please do that. I'll give you a few minutes before I get into today's lecture. So, how many? So type your name. I'm going to ask a question. Well, I'll just ask the question. If you put your answers in Blackboard, yes or no? Just send me back an answer. Have you put your answers to homework 3.1 in Blackboard? And if you have not, go there now and put your answers there. Okay, I'm giving Lanisha a few more minutes to put her homework in, and then we will start. I'll give her about 3 more minutes. Okay, great. All right. So I'll see those grades later, but I saw some of those grades earlier, and those grades were some were excellent, some were pretty good. What I want to say is this: with us being in this environment where we are relying on the internet as opposed to having a face-to-face lecture, I'm not able to give as many quizzes to understand if you are actually following. Normally, in the regular class session, I give you the homework, and then the next day I give a quiz on that homework to make sure you understand, because oftentimes students will go and find the answers, and then they will just put those answers on this the Scantron in the class setting, and of course they get a good grade in the homework. But those same students will fail the exam on almost the exact same question. So what I want to emphasize now is, even though you are putting the homework grade, getting a good homework grade, if you are not doing your own work, then you are not going to pass the exam, which counts for the major part of your grade. Let me emphasize, I don't discourage you from looking for the answer. Just make sure you understand how that answer is achieved. And for that reason, I do not change many of the exam questions that you may be able to find somewhere else. I mean, the homework questions, because I want you to get the right answer. So that if I change it and you couldn't find it, you wouldn't know whether your answer was correct or not. So there is an advantage to you working the problem out and then verifying your answer is correct, because it's the same one you found from whatever resource you used. So please don't take it lightly that you are to solve the problem, not just give me the answer. With that being said, I want to move to our lecture for today. Today we're going to be discussing relative motion. Now, what is meant by relative motion? It simply means that what is the motion with respect to some other moving object? So the good example we have here is on the screen. You notice that we have a ground-based observer who is observing the motion of a person who's on a train. The person is walking at 2 meters per second in the same direction that the train is moving. And the train is moving at 9 meters per second. So for an observer who's standing on the ground, who's not moving, the passenger has motion of 11 meters per second. Think about when you're in the airport and you're moving on the moving sidewalk. If the moving sidewalk has a certain speed and you're also walking at a certain speed, to a person who's standing motionless, you're moving at your speed plus the speed of the moving sidewalk. That's an example of relative motion. So, of course, if you were only moving at 2 meters per second, you will only get to your destination moving at a rate of 2 meters per second. But say, for example, you're moving at 2 meters per second, but the moving sidewalk is moving at 3 meters per second. Then you're going to get there at a speed of 5 meters per second, because you're moving, and the moving sidewalk is moving. So I hope that will clear up to you what is meant by relative motion. Now, what I want to show you now is how this is to be understood. And if you can grasp this, what I call nomenclature, in other words, how this problem is written, you can use this as your model. You notice that oftentimes what I want to give to you is a model. A model class is just a way to solve this type problem every time and arrive at the correct answer. So notice then what is written here. we have the velocity of the person with respect to the ground. Now, you notice that the first subscript here is the first subscript here. And the last subscript here is the last subscript here. And the middle is identical. Now, what do these subscripts stand for? Well, the P just stands for person. The G stands for ground. The T stands for train. So the velocity of the person with respect to the ground is equal to the velocity of the person with respect to the train plus the velocity of the train with respect to the ground. And these are moving in the same direction. So I simply add these two velocities together, as you can see here in this picture. Okay, now my question to you is, what would be the velocity of the person with respect to the ground if the person was walking in the opposite direction? In other words, the train is moving forward, but the person is moving in the opposite direction. So put in chat what you think that velocity would be if the person is moving in the other direction at the same speed of 2 meters per second. So I'm going to go to chat and you tell me what you think the ground-based observer would see. Okay, let me go to chat and see what you're putting there. Okay, I'm looking for a number, just a number. What do you think the ground-based observer would see? Everyone, please give me an answer. That way I know that you're paying attention or you have some guess. Okay, very good. Give me some units though. It should be in so many meters per second. Okay, look at it again, Keston. Keston does not have a good understanding. Look at it again, Keston. He's moving in the opposite direction in this in my next example. Okay, I'm looking for Keston to see what his error is. Very good, Alexi. Okay, Keston, very good. Now you understand it now. All right. Okay. The others, if you can go ahead and give your answer, I need to go on with the lecture. All right. Now, in this case, this is what I asked. What is the velocity? Oops. Let me see. Let me go back. Okay, in this case, I want to know the velocity of the person with respect to the ground. And in this case, what you noticed in, because I saw how you did the work, you said 9 minus 7. The velocity of the person with respect to the train, in this case, this value is negative 2 meters per second. Because clearly, this person is the value here is not positive, because we said that anything that moves to the west would be considered negative. So that's why you put in a negative 2 meters per second. Then the train is still moving forward at 9 meters per second. And therefore, your velocity of the person with respect to the ground is positive 7 meters per second. Hope you understand that. Okay, any questions? Do I need to go over this page again? Now, please again, notice how we have to write the subscripts, because now with relative motion, something is moving with respect to something else. So let's look at our next example. Here we have crossing a river. The engine of a boat drives it across a river that is 18 meters wide. The velocity of the boat relative to the water is 4 meters per second, directed perpendicular to the current. So here I have my boat, and the boat is directed across the river. But we see there's a current, and the current is moving perpendicular, okay? So that means that this is going to make a right angle. And the question is, and also it gives you the velocity of the water relative to the shore. So we've got to have some subscripts here. The question then is, how are we going to write this? Now, if you're at home doing your own work, you can choose your own subscripts. You may want to say shore or ground. You want to say, maybe want to say the relative to the river. All that will be at your discretion. The only thing is you have to be consistent with your own subscripts. So let's see what the author uses. The author says, okay, the velocity of the water with respect to the shore, that's the current. You see, 2 meters per second. Look what it said here. It said that the velocity of the water relative to the shore is 2 meters per second. Then he has the velocity of the boat with respect to the water. So the boat can move in the water at 4 meters per second. Again, the velocity of the boat relative to the water is given and is directed perpendicular to the current. So this is what my this is what my picture looks like. Do you notice then that we have to then solve our relative motion problem with respect to these subscripts? So the author says, what is the velocity of the boat with respect to the shore? So notice what I have here. This one, this subscript is first, and this subscript is last. And these two are the same. So looking at this picture, clearly you see that these are at right angles to each other, and I have to use my Pythagorean theorem, because we have already learned when we add vectors and these vectors make a right angle, that we use Pythagorean theorem. So I want to know, what is this velocity vector? I hope you saw in the homework now that we can use these arrows to represent any vector. It does not have to be just displacement. Now we see it can also be velocity, as long as we label the vector with what it is. So now this vector is no longer displacement, it's velocity, but it's treated the exact same way. So therefore, I have my velocity of the boat to the shore as the diagonal of this right triangle. And when I solve that, I have 4.5 meters per second. Now, because it's velocity, I need both the magnitude and the direction. So clearly, I say inverse tangent gives me what? Opposite 4 meters per second over adjacent 2 meters per second. And I have my angle north of 60, okay, north of east. So comma, north, east. That is my vector. Magnitude and direction. Okay, next question. How long does it take for the boat to cross the river? Now, what we could do is we could find out what this distance is. We could actually find this out, but it's not necessary. The reason it's not necessary is because of what I tried to explain to you in the last lecture. Time is time. The time is a scalar, which means then if I already know this distance, which is given, I can simply divide it by the speed for this distance to find the time. Please listen carefully to what I just said. In these problems, time is a scalar. Time is not dependent upon direction. So if I want to find, as the question says, how long does it take for the boat to cross the river? And we know that time is defined as distance over velocity. Then if I know the distance of any of these, which I do know for the boat crossing the river, then I can just find the speed of the boat crossing the river and I can find my time. So that's what I do. I know the distance, because it was given, of the boat crossing the river. Even though the boat we know was pushed at an angle, the boat actually landed right here. But it doesn't matter because time is time. So I can just put in the time it takes the boat to cross the river, which is given, and solve for, the speed and solve for the time. That means then in the exam, although you may be tempted to find out what this distance is, it's not necessary, but you could, because now that I know this distance and this angle, of course, I can find out what this distance is, right? I can find out what it is. And if you want to do that to prove that the answer is still going to be 450 seconds, you can do that. In other words, class, who can tell me if this distance is 1,800 meters and this is my angle theta, what is this distance? Okay, so let me go to chat and see if who knows what this distance is. How far down river did it go? Let me see. Okay, I'm waiting to see. Okay, I got one answer. Let's see if someone else can give me the answer. I'm looking for a few more answers before I go through this. Okay, so my question then is, I'm asking you, what is the length that the boat travels from here to here? What is this length? And of course, if I know what my angle is, we just found the angle, all right? We set second function tangent 4/2 to get the angle. Okay, very good, very good. Keston got an answer very close, very good, okay? All right, now what I'm saying to you class is this. If you solve for this distance, using the fact that this angle is 63 degrees, it's actually 63.43, it's in your calculator, okay, 63.4, I'll say 43 degrees. Then I know that the sine of theta is opposite, which I know, over adjacent, over hypotenuse, which I'm looking for, right? So my hypotenuse then is going to be 18 divided by the sine of theta. And when you solve that, you should get something really close to, let me see what it is. 1800 divided by, hold on. Okay, 1800 divided by sine of, let's see, theta was what, 63 point something? Okay, 2020. Okay, so the answer for this distance that the boat actually travels is approximately 2020 meters. Okay. Now, if it does that at a speed of, the speed we just calculated earlier was 4.5 meters per second, 4.5 meters per second, then we will get approximately what? So we got that, we divide that by 4.5, and we get 448. So we get 448 seconds. Okay, so still we get, if we put 2 sig figs, what happened? Hold on, let's see what's going on. Let me see. Hold on, let me see what's going on. Okay, do you all see this? I'm writing T equals 450 seconds if I do 2 sig figs. Okay, does everyone hear me? Yes or no?
Yes.
Okay, great. So I hope you see now what I've just done. What I'm showing you is that there is no need to do this second step of finding out what this distance is. See, the question says, how long does it take for the boat to cross the river? And we know that time is distance over speed. But since I'm already given the distance that the boat, it says the engine of a boat drives it across a river that is 18 meters long. The velocity of the boat relative to the water is 4 meters per second. So that's given. So by that being given, I can find the time by putting in the length that the boat travels over the speed that the boat travels. And that gave me the same answer as if I had solved for this distance over the speed of the boat to the shore. I hope you understand that. Okay. All right. With that being said, then I have concluded chapter 3. If you notice what I sent to you. I sent you the abbreviated lecture notes, but you are responsible for the content of the entire text. But I've highlighted for you what the author is trying to show you in this entire chapter. With that being said, I'm going to go to the homework now and review for you some of the key points that the author is trying to bring out in this chapter. So let's go to the homework now. We try to find the homework. Okay, do you all see the homework? Just answer yes or no. Do you see where it says the problem number 1? Yes or no? Just answer, please.
No, we see the folder.
Okay, hold on. Okay, how about now?
Yeah.
You see problem 1?
Mm-hmm.
Great, okay. All right, class. So in problem number 1, this is displacement. So we are familiar with displacement, okay? My park ranger standing here. He's standing 9.5 meters from the base of a tree. He can observe the top of the tree, which is here, at at an angle that's given. So this angle we know is 65.2 degrees. So if we know the angle theta, we can find out this part of the tree. But of course, it told you that his eyes or his height is 1.8 meters, okay, above the ground. So of course, the tree doesn't start in just mid-air. The tree has to start where? On the ground. So the tree starts here. So once you find this height, this part of the tree, of course, you must add the 1.8 meters. So how do you find this? Well, you know a leg, and you're looking for the other leg. So that, of course, tells you you're going to use tangent. And tangent of theta is opposite over adjacent. And once you find that opposite length, you add it to 22, add it to 1.8, and you get 22.4. So you're looking for this opposite, so you can add to that 1.8. Okay, next question. And the next question, what is the magnitude of the displacement of the toolbox from A to B? So here I am at A. Let me see. Here I am at A, and I want to know the displacement from here to here. So of course, displacement means from where I start to where I end. So of course, I need to know what is my Y component and what is my X component. So clearly X is 6.6 plus 5.4, and Y is above the ground 5 meters. So once I know what Y is, and what x is, of course, I use my Pythagorean theorem to find out what my displacement is. When you solve that, you should get 13. Stop me if you don't understand. I have to move kind of quickly because we only have enough time to finish this homework, because I'm going to give you the second set of homework in just a minute. Okay, similar question. Now on these questions, I suggest that you simply use a picture. The delivery truck goes north so much. He makes a turn and goes left so much. And then he goes north again so much. So now I need to find his displacement again from where he started to where he ended. So I need to know what is my total y, what's my total x, and then I can find here my displacement vector. Also, I can find my angle measured north of west. Now I want you to notice something here. In this problem, the author, once you found the displacement, you're going to circle this answer because the 4.19 was the displacement. But I want to let you know in the exam for a question like this, I may also have 4.19 kilometers and the complement of that angle. So if I gave you 17.4, okay, north of west, that would, of course, be this angle. So that angle is not 17.4 north of west. So another choice that could be correct, of course, would be this angle, measured from the positive axis, the positive x-axis, which is east, measured with respect to due east. So be careful now. Just because you can get this part of the answer, in the exam, I may have this answered 3 times, making sure you understand how to find the angle. So I could have that. I could have 4.19 kilometers, and then that angle would be 180 minus 72.6. Okay, 107.4, okay, degrees. That's correct. So I may not have this particular answer. This may be my answer. Rather than B, I could have this for B. So you hope you see now why it's important to understand how to find the angle. The author is in this homework is making sure when you do it correctly that you see there's one distinct answer. In the exam, I want to make sure that you aren't memorizing answers, but that you know how to solve for the answer. Hope that's clear. Okay, number 4. A car travels due east. This represents 22 meters per second due east. He turns due north. This represents 22 meters per second due north. So he went from here to here. Again, what is his change in velocity? In other words, he was here, but now he's here. So the change then is the magnitude of this, which is my hypotenuse, and this angle. Now, of course, you know the angle because it's 22 and 22, so it's 45. But the question is, oh, I'm sorry, he went due south. Let me take this off. Give me a minute, hold on. I see my error, okay? First he goes due east, and then he goes due south. So he's down here, he's in this quadrant, okay? Now, this is 22, this is 22. So clearly this angle is 45. That much you know. But 45 where? South of east. Okay. Now, oh, they have it marked incorrectly, don't I? He went what? He went south of east. So this should be an answer right here. South of east, not south of west. Let me make sure. He goes east and then he goes south. So this is my answer. Okay, so I have an error. I have to fix that. South of east. Okay. Now, remember I told you how important it is to recognize some of your triangles. And this is a good example of a 3, 4, 5 triangle that you should recognize. Makes these questions so easy to answer. So during a 1-hour trip, a small boat travels 80 kilometers due north and then east. So without having to do any work, I recognize this as a 3, 4, 5, a 3, 4, 5 right triangle. And once I recognize that, then I'm able to do the problem so much easier and quickly, because I say to myself, what are the factors of 3 and 4 that gave me 60 and 80? And of course, that will be what? That will be 20. So 20 times 5, that's 100. No work to be done. I just recognize it. So now I know that the displacement is this vector, that's 100 kilometers. The average speed, the speed, of course, is the distance over the time. 80 plus 60 is 140, 140 per hour. That's easy. The velocity is the displacement over time, 100 kilometers per hour. That's easy. The direction, well, I asked myself, what is my largest side? My largest side is opposite. Therefore, my angle is my larger angle. My larger angle on 3, 4, 5 is 53.1. So I did those problems so quickly just because I know my 3, 4, 5 right triangle. Okay. Next problem. Let me see. Do I need to slow down and go over anything again? Let's see what somebody's saying over in chat. Let's see. Keston, you said no. What was the answer when I asked the question no? When you gave the answer no, that's been a few minutes ago. So do you recall what you were answering when you said no? Okay, great. All right, thank you. You can see the file. Okay, great. Okay. Now, let's take a little time and work this problem out slowly. I want you to see what is going on in this problem. It's very important. The eagle is flying due east at 8.9 meters per second, carrying a gopher in its talons. The gopher manages to break free at a height of 12 meters. What is the magnitude of the gopher's velocity as it reaches the ground? Ignore air resistance. What that means, class, is the gopher is initially moving 8.9 meters per second to the east. That's what it means. That simply means that the initial velocity in the X direction for the gopher is 8.9 meters per second. The initial velocity for the gopher in the Y direction is 0. It's only in the X direction. Now, when the gopher falls, because it had motion initially in the X direction, the gopher cannot fall straight down. It's like when you throw something out from your hand, it has to go like this, which is half of a parabola. So that is its trajectory. It moves like this. Now, if you recall in our notes last time, and I'll pull it up for you very quickly so I can show it to you. Let me go back. Hold on. What do you see? I don't know what do you all see?
See the problems.
The problems. Okay, hold on. I don't want to do that. Hold on. Okay, what do you see now? Do you all see?
Presentation.
Do you see the airplane?
Yeah.
Okay. So this is the same problem. This problem is modeled just like the one for the gopher. Okay. So here we have the eagle flying. That's my airplane. This is my gopher. He falls out at 12 meters above the horizon, and it falls like this. So this velocity v here is what I'm looking for. And of course, this velocity, final velocity, has an x component and a y component. So the x component is given because remember, there's no acceleration in the x-axis that remains constant. So I need to find out what is the velocity in the y direction. And remember, I explained to you that the motion in the y direction occurs just as if the x was not there at all. In other words, we've already learned that when the object is dropped from rest, it falls down. And it has some final velocity here that is because it is being accelerated due to gravity. So that means then, if I know this distance and I know the acceleration due to gravity, I can find the final speed once it hits the ground. So let's go back to our problem. Okay, so what we have now is my gopher, and we said it falls like this. So I want to know how far, what is the speed in y, and what is the final speed in x. Final speed in x, final speed in y. So x I already know because that's given. So I want to find the final speed in y, the final speed in x. The final speed in x is 8.9 meters per second. That's given. Now to find my final speed, I need to know what are these two legs. Okay. But what I do know is that the initial speed in y is 0. The object accelerates under the influence of gravity, which is negative 9.8 meters per second squared, and it falls y negative 12 meters. So this is what I have given. And from there, I can find v final in y. But not only that, because the equation I'm going to use is, I'm going to drop down here, I'll erase it later. V final, we know, is v final in y squared, take the square root of that, plus v final in x squared. So what I really want to find is v final in y squared. And guess what? We have an equation that says v final squared is v initial squared plus 2ay. So v final in y squared is v initial in y squared plus 2ay. V initial in y squared is 0. So what is v final in y squared? It's 2 times a times y. So once I find that number, I put it here and I can solve for v final. So please go to your calculators. First of all, tell me what is v final in y squared. Put that in first. Then, after you give me that, what is v final? Okay, I'll give you a few minutes to put that in chat. I'm going to give extra credit to those who give me the answer first. Give it to me privately in chat. V final in y squared, which you're solving right here, and then v final. Give me the answer with 3 sig figs, and that way I know you are putting it in your calculator. Give me 4 sig figs. That way I know you really are doing it. V final in y squared. Okay, I see someone is blinking. Let's see who gave me an answer. Okay, very good. Very good. All right, Nigel and Keston. Very good. Gave me V final. Now, the first answer that Keston gave me is correct. V final in y squared. But I want V final, not V final, not the square root of V final in y. Okay, so Nigel and Keston, look at what I'm asking you to solve the next time. The next time I'm asking you to solve for V final, not V final in y. You see, I said to you that V final.
I got it. I'm sorry.
Okay, great. That's the question. It goes, you're solving this now. Okay, so I'm looking for V final. Let's see who's going to give me that answer first. So far, it's like Keston and Nigel are my 2 top students right now today. I'm looking for, I want to give me 4 sig figs. What is V final? Right here, we're solving this one. Okay, let's see. I see it blinking. The Nigel, very good. Keston, very good. Okay. Now, I'm getting answers from Nigel and Keston. I need to know what are the others. Are you having difficulty? And if so, let's come off of mute and let me know what you're doing incorrectly. Like Alexa, your answer is not correct. So I want to know what did, okay, let's see. Let me find my answer. Hold on. I'm at the top. Forgive me. Okay. Alexi, Lex, let's see what you're doing here. Let me show you. Let me walk you through it again. Okay. If you notice, V final and y squared was 2ay, which you should have gotten. You've got 2 times 9.8 times 12. So you got 235.2. 235.2. And this, of course, is meter square. I'm sorry, I'm writing in the wrong place. 235.2. Put in the correct units, you're going to have meter square, second square. Let me take the, let me see. Okay, that's what you got when you said 2ay. Remember, a was negative, y was negative, and therefore your answer is positive. Now, to solve for V final, you're solving you're solving for the hypotenuse of this right triangle. So V final and y squared, that answer you already have. So V final then is going to be the square root of 235 plus V final in x squared, which is 8.9 squared. And once you add these two numbers together and take that square root, you should get something like 17.9 something. Okay, let's see what we have in chat. Let me go to chat. Okay, Alexi, the answer you gave me was not 17.7. That's why I wanted to correct you. Do you see the error now that you made? Try it again, Alexa. Give me a different answer because the first answer you gave me was not correct. So give me your answer now. I'm waiting for Alexa to give me the correct answer. With 4 significant digits. Okay, Alexa, I don't see your correct answer. I'm gonna have to move on. Lanisha and Keston and Nigel, I think you three understand. The others, I cannot tell if you understand or not because you're not giving me any responses. Okay, let's see. Okay, Alexa, I'm waiting for you to give me an answer. The reason why I'm trying to see in chat what answers you're giving, because that will allow me to see where in the problem you are having difficulty. And we can go over that again. Okay, Alexi, very good. All right. Now, in the lecture today, I see we have Monier, Nigel, Lanisha, Kendra, Alexi, and Keston. So I did not receive answers from everyone. That makes me think that the others of you are not solving the problem. Monier, I don't see your answer. Kendra, I don't see your answer. So that makes me think Lanisha. I see your answer. I have Alexi, I have Nigel, and I have Keston. So do you if you don't understand, please say so. We can treat this the way we would if we were in the classroom. And you would say, Dr. Edwards, I don't understand. That will give me a chance to either have a private session with you, which we can do, or we can yes, a private session. Because I don't want to spend too much time on this. We're at 2:32 already, and I got to finish a few more problems. Okay, let me clear the board. Okay, let's answer these questions. Am I still sharing the homework?
Yes, ma'am.
Great,
Yes.
okay. A football is kicked at an angle theta. So that means that the football is kicked at an angle. Which one of the following statements best describes the acceleration? This problem is telling you that the only acceleration the ball has is that's due to gravity at all times. And we know what that acceleration does. If an object is kicked up at an angle, at its highest point, that object has has velocity in y that is 0. It means then that at this point, the velocity in x is still there. In other words, it does not stop moving in the x direction. The object does not rise and then boom, fall down. It doesn't do that. It falls like this, which means then at an instant in time, the velocity in the y is 0, but the velocity in the x is constant. It's whatever it was when it left from this point. The velocity in x is constant throughout the flight. Only the velocity in y changes. So the next question tells you that the x component of the velocity of the ball is the same throughout the ball's flight. That's important for you to remember, because some of the problems you're going to have in the exam will question your understanding of this concept. Okay. Okay. A tennis ball is thrown from ground level with an angle 30 degrees above the horizontal. Now, what we know then is the ball is thrown and it follows this path. At the very top, the velocity here in y is 0. That's all we know so far, but we know more than that. But it says it's thrown at an angle. So this is 30 degrees. Again, notice this author gives you one of our familiar vectors, a 3, 4, 5. I'm sorry, a 30, 60, 90. So that means we can solve this problem even more quickly, because now we know what these values are. And I hope you notice too that the values here a representative of velocity, distance, speed, whatever I need it to be. It's still going to be resolved using this picture. Now, if it takes 0.5 seconds to reach the top, what is the magnitude of the initial velocity? So that means then that the initial velocity, okay, and we know that the velocity along the x and y is given by the equation v initial and y. We said it's v initial times the sine of theta, and v initial and x is v initial times the cosine of theta. So it says that the tennis ball is thrown from ground level with velocity v initial directed 30 degrees above the horizontal. If it takes the ball 5 seconds to reach the top of its trajectory, what was the magnitude of the initial velocity? So we know that the final velocity in y is equal to the initial velocity in y plus the acceleration in y times the time. The final velocity in y we can find because it's equal to what? A sub y times time, and time is given. So we can find the final velocity in y. Okay. Now, the same thing is true for what? It's true for x. But what we know is if it takes the ball 5 seconds to reach the trajectory, we're looking for this time. So we can find what? The initial velocity in y, because final velocity in y coming here, we know is 0. So we can find out the initial velocity in y, then come over here and solve for what? V initial. So we got a few minutes. Who can solve this problem quickly? You got 2 problems to solve. First, find out what V initial and y is. Then once you find that, come over here and find V initial. Okay, I'm going to see who's paying attention. Do you understand what I'm asking you to do? Yes or no? Just say, come off mute, yes or no. If you understand what I'm asking you to do. Everybody's gone?
I'm still here.
Okay, do you understand what I'm asking you to do?
Mm-hmm.
Okay. All right, I'll give you a few minutes to work on that.
Is it V initial Y plus AGT?
Well, it's not AGT because in this case, A is G. A is negative 9.8 meters per second squared, which is A sub Y. Is that what you're asking me?
Yeah, because it looks, I can't really see. It's kind of small, so I wasn't sure if that was an A or a G.
Okay, A sub Y, which is G, means acceleration in the Y direction, which we just said was always constant at 9.8 meters per second squared. It's always that. Okay. Okay. I'm not sure. Okay, very good. Nigel gave me the first answer, 4.9. Okay. But the question was, what is the magnitude of the initial velocity? The initial velocity is v sub I. And v sub I would be v sub I in y divided by sine of theta. And when I solve that, I get 9.8 meters per second. So I just observed something. You see, I took these answers, I took these very questions from the textbook, from the author. So if you solve this question yourself and you saw that the answer was B and you chose B because that's the correct answer, but the author said the answer was A, which is incorrect, that gives me a clue that you're getting your answer from somewhere else. In other words, in this question, as you can see, clearly the answer is 9.8. We solved it. But if you answered it as 4.9, where did that come from? Because the question is, what is the magnitude of the initial velocity? Not the velocity in y, which was your first answer, but the velocity of the what? Of the trajectory initially. So make sure then that you're not just getting your answers from the book, because as we can see, even the book has some incorrect answers, and this is one of them. Okay, so this will end our lecture for today. If you've put your answers in Blackboard, I will be able to grade those. The other questions, if you want to go over those, we can. I wanted to ask you also if any of you are free to go longer. And I don't want to do that unless over half of you can do that. If most of you, I have 9 of you in the class. If 5 of you cannot stay longer, then I won't do it. I can only do it if the majority can stay longer. So beginning tomorrow, please let me know if you can stay a little longer so that we can complete this chapter. Tomorrow, I will be reviewing the homework that I'm about to give you for today. So the homework for today are problems that have to do with relative motion, which is what I gave you at the first part of the lecture. So look for those problems first in your email. And then secondly, I see now that I can put a part of that question in Blackboard. As you notice in Blackboard, I cannot put the entire question because of it not being able to support pictures. But I can put enough there that you know which question I'm referring to because it's also in your printout from your email. So 2 things. I'm going to give you the time today to work on the homework. And then tomorrow, between say 10 and 11, I'm sorry, 10 and 1, if that's enough time, I'll give you about 30 minutes to put the questions in Blackboard. In other words, you've already worked it out. So when you see it in Blackboard, just a matter of you just choosing the answer. Does that make sense?
Yes.
Okay, great. All right. So please go down to chat and sign out, and I will say goodbye. We're exiting now. Okay, Nigel, you can explain your question.
What I was saying is, with extending the time, I can do 15 minutes, but I'm working from home, so
15 minutes.
I don't know how long you want to extend the class.
Oh, 15 minutes. Okay, yes. I was thinking about going to 3 o'clock. Yes.
Okay, that's doable.
Yeah, okay, great. Yes, that'll give us just a little bit more time, and mainly just to answer your questions, because I want to reiterate the fact that we're actually being shortchanged in this class. The persons who put our time in Banner did not give us enough time, and they did not say that it was asynchronous or synchronous, or hybrid. See, hybrid means that we would have 5 hours of contact time and then 5 hours that you are to work independently at home, which we're sort of doing. That's why I'm trying to give you homework and other work to do each night. And unfortunately, we don't have the convenience of a day in between, but still is what we have to do. So we're signing out now, and then you can go and look for your homework, which will show up shortly in your email. And I'll put it on Blackboard. Okay, have a good evening.
All right, you too.
Okay.